In the last lesson, we discussed about stopping side distance and also decision side distance. Today, we shall talk about three other types of side distance: overtaking side distance, intermediate side distance and headlight side distance. After completing this lesson, the student will be able to appreciate the need for providing overtaking side distance OSD, intermediate side distance ISD and headlight side distance HSD, why they are necessary and where we should apply them. Student will also be able to identify influencing factors and understand the basis for suggesting design values for overtaking side distance. Why it is necessary to provide overtaking side distance? Wherever there are two-lane roads with two-way traffic movement, often vehicles moving at higher speed, they are required to overtake slow moving vehicle. This requirement is more when the traffic is heterogeneous in nature. Slow moving vehicle, fast moving vehicle, they all share the same road space. Therefore, often fast moving vehicles, they require to overtake slow moving vehicles. Therefore, adequate side distance should be available so that faster moving vehicles can overtake slow moving vehicle without hitting another vehicle which is coming from opposite direction. So, formally if we see minimum side distance that should be available to a driver for overtaking another vehicle safely. It is worthwhile to mention that restrictions for passing opportunities affect the level of service for highways, particularly two-lane, two-way roads, as the measure of effectiveness for defining level of service for such facilities include percent time spent following and average travel speed. Once there are adequate passing opportunities, obviously lesser time vehicle have to spend following slow moving vehicles, and also the average travel speed will be different. Once more passing opportunities are provided, average travel speed will be higher. So, therefore, if we provide adequate passing opportunities or overtaking opportunities, then the level of service are expected to be better. Now, how the overtaking maneuver take place? Overtaking vehicle follows the slow vehicle for some time. Initially, faster moving vehicles, they have to follow slow moving vehicles. Subsequently, a faster moving vehicle finds a favorable condition for overtaking, available side distance, and also he looks opposing vehicles, whether there is any vehicle which is coming from opposite direction. He finds a favorable condition, then pulls out the vehicle, overtakes and returns back to original lane before meeting an oncoming vehicle from the opposite direction. So, that is what is the process for overtaking. While estimating the design requirement or design value, certain assumptions are made, like number 1, a single vehicle overtaking a single vehicle. It may be possible that in some situation or there are occasions when multiple overtakings are happening, but for design purpose we do not consider multiple overtaking, because simple reason is then the required values will be much higher. Also, the design values are required minimum values. Therefore, if we consider multiple overtaking operations, then the minimum requirement itself will be higher. It is not desirable, it is not necessary. So, therefore, a single vehicle overtaking another single vehicle and the required overtaking side distance for that condition, that is what is our subject for discussion. Then overtaking vehicle travels at uniform speed. This is another design assumptions, that overtaken vehicle traveling at uniform speed, no acceleration or deceleration is applied by the overtaken vehicle. Third, overtaking vehicle follows the vehicle ahead for a short while, then overtaking vehicle accelerates rapidly, pulls out, occupies the opposing lane, overtakes slower vehicle and returns to original lane. That is the way overtaking normally takes place. Then vehicle travels from opposite direction at the same speed as the overtaking vehicle, because remember that we are talking about two lane roads with two way traffic movement. So, obviously, there is a possibility that a vehicle is also approaching from the opposite direction, and the required side distance also will depend on the speed of the vehicle from opposite direction. So, it is assumed that the vehicle from opposite direction is also travelling at the same speed as the overtaking or passing vehicle. Then difference between average speed of overtaking and overtaken vehicle is 15 km per hour. This is again a design consideration considered by AASHTO or in formulating their recommendations, that difference between average speed of overtaking and overtaken vehicle is 15 kilometer per hour. In reality, it may vary, it may be different than 15 kilometer, but for design purpose this difference is taken as 15 kilometer per hour. Similarly, speed of overtaken vehicle is assumed to be 16 kilometer per hour lesser than the design speed of the road. You are already familiar with the term design speed. This is the assumption based on or this is the assumption considered by Indian Roads Congress while recommending the design values for OST. So, IRC or Indian Roads Congress assumes that speed of overtaken vehicle is 16 kilometer per hour lesser than the design speed of the road, but AASHTO assumes that the difference between average speed of overtaking, this average speed is not the design speed. So, the difference between average speed of overtaking and overtaken vehicle is 15 kilometer per hour. Like stopping side distance, for overtaking side distance also it is necessary to specify the height of driver's eye above road level and also the height of object above road surface. In this condition, for overtaking or passing, the opposing vehicle is also opposite object is an opposing vehicle. So, therefore, the height of driver's eye above road surface and height of object, they are the same. As per Indian Roads Congress recommendations, it is 1.2 meter. As per AASHTO recommendation, it is 1.08 meter. 1.2 and 1.08 were used while estimating the required stopping side distance as per IRC and AASHTO respectively. So, it is the same value. Now, how the overtaking side distance can be estimated? There are different approaches for estimating the overtaking side distance. We shall discuss about 3 different approaches. Approach 1 is shown here. There are 3 vehicles which are involved in the overtaking operation: vehicle A, vehicle B and vehicle C. Vehicle A is the overtaking vehicle, vehicle B is the overtaken vehicle and vehicle C is the vehicle which is coming from opposite direction. Initially, vehicle A follows vehicle B and looks for an opportunity, suitable opportunity for overtaking. So, by the time it changes its position from A1 to A2, then it completes the overtaking operation as shown in the sketch. It encroaches the lane which is supposed to be used by vehicles from opposite direction, completes the overtaking operation and then comes back to its original lane. So, in the complete process, the vehicle changes its position from A2 to A3. When vehicle A is overtaking slow moving vehicle B, then vehicle B is also moving. So, let us look at the sketch. Vehicle B is changing its position from B1 to B2, and during this overtaking operation another vehicle is assumed from opposite direction, which is vehicle C, and when vehicle A is overtaking vehicle B, vehicle C is changing its position from C1 to C2. Now, the speed of overtaking and opposing vehicle is assumed to be the same. So, it is taken as say v meter per second, and the overtaken vehicle or the slow moving vehicle speed, let us assume it as v b meter per second. Now, the total required overtaking distance is d1 plus d2 plus d3. So, that much side distance should be available to the driver of vehicle A when it is starting the overtaking operation. So, let us see how we can calculate each and every component, that is d1, d2 and d3. Now, d1 is the distance travelled by vehicle A during the perception reaction time. You are already familiar with this component, perception reaction time. We used perception reaction time when we calculated the stopping side distance. Here also the same component is applicable, but the design value is taken as 2 seconds. I repeat, the design value of perception reaction time is taken as 2 seconds. So, during this perception reaction time, vehicle A or the overtaking vehicle is forced to follow the slow moving vehicle in front, that is vehicle B. Therefore, the distance d1 equal to v b multiplied by t. It is v b, not v, because the slow moving vehicle is in front and the faster moving vehicle is forced to follow the slow moving vehicle during this time period. Now, let us see how we can calculate component d2. d2, from the sketch it is clear that d2 equal to b plus 2s. B is actually the distance travelled by the slow moving vehicle B during this overtaking time t, and S is the minimum required spacing between two vehicles. So, just before overtaking and after overtaking, S gap or S distance is kept between vehicle A and vehicle B. So, therefore, the distance d2 is B plus 2s. Also, if we consider the fast moving vehicle, then this distance d2 can also be estimated as Vb into t. Vb is the initial speed of vehicle A plus half a t square, where a is the acceleration applied by vehicle A and t is the total time required for overtaking maneuver expressed in second. So, therefore, d is equal to b plus 2s, and again d2 is equal to Vb multiplied by t plus half of a t square. Now, b is again Vb multiplied by t, because the slow moving vehicle during the complete time capital T is covering this distance and the slow moving vehicle is travelling at uniform speed. Therefore, B is Vb into t. So, therefore, as a result we find that 2s is equal to half a t square, or t is square root of 4s by a. Now, s is the spacing minimum spacing between two moving vehicles, which is also often taken as 0.7 VB plus 6. This is an empirical formula. VB is expressed in meter per second, and S, the spacing, is also expressed in this empirical formula in meter. So, therefore, once the speed is known, the VV is known, one can calculate the S, and also another input required is A in order to calculate the total overtaking time T. The A value is also recommended depending on the speed. For higher speed, the acceleration is lesser, and reverse thing, that means for lesser speed acceleration, maximum acceleration values are relatively higher. So, with the value of A and S, one can calculate the total time required for overtaking, and then accordingly this distance d2 can be calculated. Now, let us see how the component d3 can be calculated. d3 is the distance travelled by the opposing vehicle C during the time capital T, overtaking time. So, it is V multiplied by T. V is the speed of the overtaking vehicle. So, therefore, the total overtaking side distance required is d1 plus d2 plus d3. Now, let us take an example. If the design speed is say 80 km per hour, maximum acceleration is 0.72 meter per second square, reaction time is 2 seconds, then what is the minimum required overtaking side distance? You know that as per Indian Roads Congress recommendation, the slower moving vehicle is assumed to travel at a speed 16 km lesser than the design speed of the road. So, when the design speed is 80, the slow moving vehicle speed is 18 minus 16. So, that is 64 km per hour. If you convert it into meter per second, it is 17.79 meter per second. Therefore, d1 is V into T if we use 17.79 meter, or it is 0.278 VB into T if VB is expressed, or the speed is expressed in kilometer per hour. So, you get the distance d1. One can also calculate the spacing between two vehicles with the help of the empirical formula 0.7 VB plus 6. So, 0.7 into 17.78 or 79 meter plus 6 meter. Then once the S is known, acceleration is known, therefore, the T value can be calculated as square root of 4 into S by A. So, which is 10.12 second. So, the distance d2 can be calculated, and d3 also with the original speed 80 km per hour and overtaking time 10.12 second, the distance travelled by the opposing vehicle can also be calculated. So, therefore, the required overtaking side distance is d1 plus d2 plus d3. In this case, the total is 477.76 meter. So, that is the required overtaking side distance for this case. Now, let us see another approach for estimating overtaking side distance. This approach is recommended by Indian Roads Congress. It is assumed that the complete overtaking operation takes a time in between 9 seconds to 14 seconds. So, 9 seconds to 14 seconds is the total time required for overtaking depending on the speed. IRC suggests that add 2/3 of this time to account for vehicle from opposite direction. Ideally, it should be that complete time, not 2/3 time, but if we take the complete time, then the design requirement or the minimum required value will be higher. It is felt that up to certain time, when the faster moving vehicle is trying to overtake a slow moving vehicle, even when it is on the opposing lane, still it can come back to its original position up to certain time. So, therefore, it is not necessary to consider the complete time while calculating the distance covered by the vehicle from opposite direction. So, a practical value is taken as based on the 2/3 of this total overtaking time. So, therefore, look at this table. For different design speed, the OSD value can be calculated. The overtaking time varies from 9 to 14 seconds. At lower speed, say 40 km per hour, it is 9 seconds, and as the design speed is higher, the required time for overtaking is also more. Say for 100 km per hour speed, the overtaking time is 14 seconds. So, in each case, 2/3 of this time is added to account for the vehicle from opposite direction. So, the total time is calculated. So, in case of 40 km per hour speed, say it is 15 seconds. So, what is the distance if the speed is 40 km per hour and time is 15 seconds? That is what is the recommended value. Only thing, the values are rounded. Now, let us see also another approach taken by AASHTO, American Association of State Highway and Transport Officials, how they calculate the required overtaking side distance value. Let us look at the sketch. Here also we have components like D1, D2, D3 and D4. D1 is the distance travelled by the overtaking vehicle during the initial perception reaction time and also during the initial acceleration up to the encroachment of opposing lane. So, it is shown accordingly in the sketch vehicle position for vehicle A, and the distance covered during this time is D1. D2 is the time for overtaking when the overtaking vehicle is actually overtaking vehicle B, encroaching or staying in opposing lane, and then it is coming back to its original position. So, that is distance D2. D3 is the clearance time after completion of overtaking. A gap is assumed between the overtaking vehicle which has just completed the overtaking operation and a vehicle which is coming from the opposite direction. If you remember the sketch which I have shown you when I was talking about the first approach, it was assumed that after overtaking, when the overtaking vehicle is back to its original lane, the opposing vehicle is just by the side of this overtaking vehicle, but in different lane. So, they were placed side by side. In this case, there is a clearance which is assumed and called as d3. d4 is the distance covered by opposing vehicles during this overtaking maneuver. So, it is a vehicle C which is coming from opposite direction. Now, let us see how each component, say d1, d2, d3 and d4 can be calculated. d1, as I told, it is the distance covered by overtaking vehicle during the initial perception reaction time and also during initial acceleration. So, this is expressed as 0.278 t1 if that time is required is t1 multiplied by v minus m plus half into a into t1. It is nothing but distance into speed multiplied by time plus half of acceleration into time square, the same basic equation. Why it is taken as v minus m? Because here also before overtaking, the fast moving vehicle or the overtaking vehicle is forced to follow the slow moving vehicle in front. Now, the difference slow moving vehicle is travelling at a speed 15 km per hour lesser than the average speed of the overtaking vehicle. So, this component is taken as v minus m instead of v. Now, experiments have been carried out for passing maneuver and it is found suitable values are found out for in terms of say acceleration and also the time taken based on different speed range. Say one speed class is considered as in between 50 to 65 kilometer per hour, the second one 66 to 80 kilometer per hour, third one is 81 to 95 kilometer per hour and the last one is 96 to 110 kilometer per hour. Field observations are made for the first three classes to find out the average acceleration and average time required for initial class for each of the first three speed range or speed class. The values are extrapolated to get a suitable value of acceleration and time taken for the speed range between 96 kilometer to 110 kilometer. So, these values are available, values of A, values of T for different speed range. Using those values, one can calculate the length d1. Similarly, for calculating the distance d2 from field observations, the required time t2 for overtaking maneuver is found out for three different speed ranges and again values are extrapolated for the speed range between 96 to 110 kilometer per hour. Say for example, for the speed range between 50 to 65 kilometer per hour, it is found that average time taken is 9.3 seconds. So, actually the average speed of overtaking vehicle multiplied by this time t2 for overtaking maneuver, that can give us the value for distance d2. Now, since v is expressed in kilometer per hour, so 0.278 multiplier is used. So, therefore, d2 is 0.278 multiplied by V into T2, and T2 values are obtained from experimental observations, and it is available in design code. Now, D3 is the clearance between two vehicles. So, it is assumed that a clearance is maintained. This value is again obtained from experimental observations for different speed ranges. Say for example, for the speed range between 50 to 65 kilometer per hour, this clearance is suggested as 30 meter. Similarly, suitable values are suggested for different speed ranges. D4 is the distance covered by opposing vehicle. Here also it is taken as 2/3 of the distance D2, not the complete distance D2, for the same reason as we have discussed earlier. You can see also from the sketch approximately up to 1/3 of the distance to D2, vehicle B is actually placed just by the side of vehicle B in other direction. So, it is assumed that even up to this position, the vehicle A can comfortably go back to its original lane if it detects any vehicle from the opposite direction. So, it is basically taken as 2/3 of D2. So, therefore, in the same way here the total OSD is calculated as summation of D1, D2, D3 and D4. I have mentioned it that here all these distances are calculated considering the average speed of overtaking or passing vehicle, not the design speed. But finally, for different or design of highways, we need to relate this required OSD with the related to the design speed. That is only possible when we find out a likely and logical relation between the average passing speed or overtaking speed and the highway design speed. Then only we can express OSD in terms of the design speed. To do that, it is assumed that the speed of passed vehicle is the speed of the traffic stream at or near capacity volume. That means, when the volume of the traffic stream is at or near capacity, then what is the speed of the traffic stream, that is taken as the speed of the passed vehicle. So, a relation is established. Then the speed of passing or overtaking vehicle is assumed 15 km per hour higher than the speed of the passed vehicle. Considering that, as shown in this table, the OSD requirements are found out. For different design speed, the assumed speed for overtaken vehicle and taking vehicle are mentioned. Say for example, design speed of 80 km per hour, it is assumed that overtaken vehicle speed is 65 km. This is assumed to be the average stream speed when the volume is approaching capacity. Then the overtaking vehicle is assumed to travel 15 km higher than that. So, 65 plus 15. So, it is 80 km per hour. Accordingly, once this average speed of overtaking vehicle is known, all the components D1, D2, D3, D4 can be calculated, because all of them they are related to average speed of overtaking vehicle. So, Similarly, these values are calculated. Say in this case it is 538. For design purpose, AASHTO recommends the value 540 after rounding this value. Similarly, for different other design speeds, the recommended OSD values have been calculated and are available in AASHTO guidelines. Now, is there any effect of grade on the required overtaking side distance? We have explored the same issue when we discussed about the stopping side distance. Let us see what happens when the vehicle is in downgrades. Here, overtaking vehicle can accelerate rapidly because of the grade. So, there is expected to be lesser time required for overtaking, but this factor is compensated by the fact that overtaken vehicle can also accelerate. On level we assumed uniform speed of overtaken vehicle, but when it is a downgrade, overtaken vehicle may also accelerate. So, therefore, they may compensate each other to some extent. Similarly, for upgrades, more side distance is required due to reduced acceleration of the overtaking vehicle and likely speeding up of opposing vehicles. So, we expect that probably we require higher overtaking side distance, but here also there is a compensating factor, that is the speed loss of speed the speed of overtaken vehicle. There is this loss in speed for the overtaken vehicle, which is frequently a heavy truck, a heavy commercial vehicle. So, therefore, these factors they try to compensate each other in some way, and generally no correction is applied for grade. We shall talk about another type of side distance now, which is called as intermediate side distance. So, we have discussed about stopping side distance, decision side distance. In this lesson, we have already studied overtaking side distance. Now, we shall talk about intermediate side distance. This design recommendation is only given by Indian Roads Congress guideline, not by AASHTO. AASHTO does not recommend anything called intermediate side distance, but it is a recommendation given by Indian Roads Congress. Sections where providing overtaking side distance is impractical for practical reasons or otherwise, that means where it is not possible to have required side distance at least equal to overtaking side distance, then the intermediate side distance is recommended, which is twice the stopping side distance. So, what is the stopping side distance requirement? We already have studied the stopping side distance. Double of that value is intermediate side distance, and it is recommended that wherever due to site condition or other practical difficulties, it is not possible to provide a side distance at least equal to overtaking side distance. In those locations or in those situations, try to provide side distance which is equal to the intermediate side distance. The idea is, if intermediate side distance is available, then that will provide a facility for overtaking at least in a limited manner, not fully, but in a limited manner it will provide opportunities for faster vehicles to overtake slow moving vehicles. Then we have another type of side distance, which is called headlight side distance. When there is a valley curve is generally concave, looks like concavity upward. So, when there is a valley curve, then during night time vehicles can see only that portion of the road which is illuminated by the headlight of vehicles. So, therefore, there is a necessity to consider this side distance for the special situation, and which is called as headlight side distance. That means, the distance available by the illumination of headlights. This headlight side distance should be at least equal to the stopping side distance, so that under emergency conditions during night time driving on valley curves, vehicle can also stop. So, the available side distance or the headlight side distance should be equal to the stopping side distance for design purpose. We shall come back to this topic, headlight side distance, and discuss in details about its application when we talk about the vertical curve design, particularly the valley curve design. So, we will come back to this topic later. Some of the questions for you from this lesson. Try to answer to these questions. Why it is necessary to provide overtaking side distance? You have studied what is side distance. So, why it is required to provide overtaking side distance, under which conditions or under which type of facilities, for which type of facilities. Then second question, when one should recommend intermediate side distance? When one should recommend intermediate side distance? Number 3, explain the term headlight side distance. Number 4, explain the basis for AASHTO recommendations about overtaking side distance, how the design values are calculated in AASHTO recommendations, what is the basis for that? Discuss the same. Now, I shall try to answer the questions which were raised during lesson 3.3. The first question was, explain the terms lag distance and braking distance. You know, lag distance is the distance travelled by a vehicle during the perception reaction time of the driver. So, when an object is visible, there is a perception reaction component before the brakes are applied effectively, which is, and the distance travelled during that time is known as the lag distance, while the braking distance is the distance covered by vehicle after effective application of brakes. That means, when the brakes are applied effectively, after that one, how much distance the vehicle takes before it comes to a stop. Second question was, explain the difference between stopping side distance and decision side distance. Now, stopping side distance, the reaction time considered is applicable for general condition, but there are certain special conditions where drivers have to make complex or instantaneous decisions, where information is difficult to perceive, where unexpected or unusual maneuvers are expected. Under those conditions, the stopping side distance and the reaction time, perception reaction time assumed for SSD, stopping side distance calculation, is not adequate. There one has to go for decision side distance. Then what are the different avoidance maneuvers considered for recommending decision side distance? 5 different avoidance maneuvers are considered. Maneuver A, stop on rural road, B, stop on urban road. A and B are essentially stop maneuver, but then there are C, D and E which are not stop maneuvers, they are speed, path, direction change. C is for rural road, D is for urban suburban road and E is for urban situation. So, all the values are different for different maneuvers. This is the last, there is a problem. The available side distance for a stretch of road with 6% downgrade is 100 meter. The design speed for the road is 80 km per hour. Is the available side distance adequate for emergency stopping of vehicle? The problem is fairly simple. You know that if we take AASHTO recommendation, then the stopping side distance can be calculated as shown here, lag distance plus braking distance. So, one can apply a comfortable or the design value for deceleration. Here the n value is negative downward slope. So, it is minus n, written as minus n. You can calculate the value, it is 144 meter, which is not which is more than the available side distance 100 meter. So, what are the options? Basically one can try to have a different grade, okay, so that the available side distance is sufficient for the stopping, or the other option is the restriction of speed. So, one has to go for speed restriction, but with proper sign marking, so that drivers know that for this particular stretch of road there is a speed restriction. So, one has to go for speed restriction under such situations.